So the force between two charges is given by Coulomb's law, K times Q1 times Q2 over R squared. So we want to double the force. We want to go from 1 newtons to 2 newtons. So our goal is to double the force. And it asks us to do this in 3 different ways. In each way, we're only allowed to change one thing. So there's basically 3 variables here. There's the 2 Q's and there's the R. So method 1 would simply be to double one of the charges, Q1. Okay, if I double Q1, everything else is the same. That's going to end up doubling my force, and I achieve my goal. Similarly, the second method to do this would be to double Q2. Okay, so if I double Q2, everything else stays the same. My force value just ends up doubling. I achieve my goal. And then the third way is a bit trickier. It's to keep the charges the same, but to adjust the distance. How can I adjust this distance so that when I do all the math, my force ends up being doubled? So the first thing you have to realize is that you actually have to make these charges get closer together. The closer together the charges are, the stronger the force is going to be. But it's actually incorrect to say to reduce the distance by a factor of 1/2. Okay, if you think this is the answer, you're going to get it wrong, because if I reduce it by a factor of 1/2, you have to realize that the R variable is squared. So you're actually doing the effect twice. You're squaring the effect. That'll actually make the force become 4 newtons. It'll be 4 times stronger. So that's wrong. So how do I do it to get my force double? Well, I have to think. Something squared has to give me more specifically, 1 over something squared has to give me 2. 1 over because the distance is in the denominator. 1 over something squared has to give me 2. So that's something. You can do algebra if you want and rearrange things. That something ends up being 1 over root 2. You can cross multiply, square root both sides, you get 1 over root 2. So method 3 would be to reduce the distance by a factor of 1 over root 2.